There are just 2 lessons left in our Math 1103 course, and we'll be doing section 5 of chapter 5, dealing now with negative exponents, and then later the scientific notation. And both of these were found on the final exam. Again, not every test might have it, but a topic you'll need to be familiar with. So we'll go over all of these learning objectives. Now, there are some rules, and I'll go over them with you. When we have a negative exponent, really, what does that mean? Well, let's look at this. A to the second is, in a sense, over 1. Now, there's also a 1 up in the numerator as well. We don't write this one and we don't write that one. But if we wanted to take this A along with its exponent down to the denominator here, for some reason or another, what would it look like there? Well, the rule is when you have a base with an exponent and you move the exponent across this fraction bar, the sign of the exponent changes. So this will become A to the negative 2. So what would 3 then to the negative 2 become, which is our first example? Well, keep in mind there's a 1 there also that we don't write, and it's over 1 that we don't write. So we leave the 1 up in the numerator. We now take our base and exponent. As it crosses the division bar, this fraction bar, the sign of the exponent changes, and it becomes this. So this is actually 1 over 3 to the second. And what is 3 to the second? 1/9. Because they're asking us to simplify as well. Now here it gets a little tricky because what is our base here? Is it 8a or only the a? And the answer is it's only the a. So the 8 is going to stay up in the numerator. This comes down as a. Crossing the division bar, the sign changes. Now here as you see it, all you're going to do is switch these around. The y goes on top, its exponent becomes positive, the x goes down, its exponent becomes positive, and that's our answer. Now this one's a little tricky because what is this? Well, again, it's 1 over 4 to the second. And what is 4 to the second? 16. And what did we say any base to the 0 power is? 1. But we now have to add these two together. In order to do so, we have to convert this 1 into a denominator with 16. So we're going to multiply each by 16, and we get 16 over 16. 16 over 16 is 1. We now add those together, and we get 17 sixteenths. We have our common denominator. We just now add the numerators. Okay, I'm going to have to erase this because I don't have a lot of room. I wish I had some nice boxes to write this out neatly, as hopefully that's what you have been doing. So Let's raise it up just a little bit. So remember, the rule is when we're multiplying variables, we just add their exponents, keeping in mind there's a 1 there. So let's add them all up. And we only want to show our answers using positive exponents. So -6, -3 is -9, -2 is -11, plus 1. This becomes a to the -10th. But that will simplify into 1 over a to the 10th. We just take it and move the base and the exponent across the fraction bar. The sign of the exponent changes. Now here we have to do some raising of powers first. Remember there's a 1 right there. So we get 2, and this is 1 times 3 is 3. So it's 2 to the 3rd power. Here, that's going to be an 8. X to the, we multiply here, raising a power to a power. This becomes 12. This is x to the 15th. Now, since we want only positive exponents, we're going to move the smaller exponent down, and this will then become 8 in the numerator. 12 down to our denominator becomes a -12, so this is x to the 3rd. Now, the nice part about this is the signs and the multiplication is all straightforward. So it's -2 times -2 makes this x to the positive 4. This is going to be y to the -16, but I'm going to move down here to y to the 16th. Now, initially it was up here. I'm saving a little room. This became a y to the -16 up here. They only want positive exponents, so I just moved it down. Okay, now keep in mind we can kind of divide this up into pieces. Here we have a -6 divided by a -12. That's going to give us a positive 1/2. Now, this x to the 2nd, x to the 5th, we're going to bring the 2 down and get x to the 3rd down there, subtracting the smaller from the larger. So we want positive exponents. Now we're going to move the y to the -6 up here. This becomes a positive 6 up there. So this gives us y to the 3rd. Now we usually don't write the 1. Okay? Now if you do and they count it wrong, I will give you full credit on your test. All right, let's clear this and go on to our next part here. Again, they're just a little bit tedious at what they're doing. Here we have m to the 2nd. Okay, can't do anything with that right yet. We're going to do this first. This is raising a power to a power. So this is going to become m to the positive 8. Okay. There's m to the 2nd. This became m to the 8th. So on the top here, we now have m to the 10th. And then this is going to be m to the -10th down there. And now we're going to raise that up, and that becomes 10 plus 10. So our answer here is m to the 20th. That's our final answer. Now, an interesting thing occurs in letter F here. If you have, in a sense, a fraction, This is sort of a fraction here. And it's to a negative power. A technique that will allow us to change this to a positive power is take the reciprocal of that. So that's what I'm going to do. 2x to the 4th, y to the 7th. I'm taking this, putting it in the numerator. 3xy to the 5th. I've taken the reciprocal of that because now I can make this a positive 3. And that's going to help with the signs tremendously. So, can we cancel anything out in here? And the answer is yes. So let's simplify within the parenthesis. Now we still get 2/3. We can't do anything with that. But the x and the x to the 4th becomes x to the 3rd. And the y to the 5th and y to the 7th becomes y to the 2nd, subtracting 5 from 7. And now this is all to the 3rd. So we're just taking something that is rather complicated and using a couple of techniques to make it a little simpler. So this is going to become now 2 to the 3rd is 8. 3 to the 3rd is 27. And then we just multiply these. This is going to be x to the 9th, y to the 6th. And let me check that. Yes, we're good on that. And that was F. Now in letter G, let's look at it. Oh, look at this. This fraction, even though it looks super complicated, is to the 0 power. What did we say anything to the 0 power is? 1. Yep, anything to the 0 power is 1. Now here we're multiplying. Notice we're not raising a power to a power. So we get negative 2 times negative 5. That's going to be a positive 10. Then we get r to the negative 3. There's no other r's, so I'm just going to move this r to the 3rd down below. S to the 2nd. This just goes down below. S to the 2nd down there. Then we have t to the 1st and t to the negative 4. When we add this, we end up with t to the negative 3, which just goes down there. So that's our answer. T stays on top. This, because of a negative exponent, goes down. S, because of its negative exponent, goes down. We did this multiplication by adding, and that became a negative 3 up there. It went down. Okay. So again, there's lots of little rules, and some of this is tedious, but you're going to give it your best effort, I'm sure. Now for scientific notation. Now on YouTube, I see there's lots of other instructors giving little lessons on scientific notation. Now, have I given any other lessons? Yes, I have the textbook where I go over scientific notation in great detail. I do a PowerPoint presentation on this. I do additional exercises on this. I do a board lesson on this. So there are plenty of lessons out there, but this is our mini lecture. So I'm going to do it in a mini way. Now in scientific notation, we have a number, this number here, that is between 1 and 10. And then we times it by a power of 10, where up here we're going to put some exponent. If it's a big number, these exponents will be positive. If they're small numbers like these numbers are going to be negative up there. So, in a mini way, what's the rule? Well, where's the decimal place right here? Well, right there. I want to move that decimal place in such a way, 1, 2, 3, 4. I've moved it 4 places to the left. So now I have a number, 8.3, which is a number now between 1 and 10, times, now some power of 10. And we determine that power by the number of decimal places we moved it over. And big numbers are positive exponents. So we moved it over 4. And there is this number in scientific notation. So again, we're going to move it. 1, 2, 3, 4, 5, 6. So our number between 1 and 10 is 1.25 times 10, and we moved it over 6 places. Now here's a case where it's a small number, so instead of there being positive exponents, they're going to be negative exponents. So we still move it over to a number between 1 and 10. 1, 2, 3, 4. So I get 1.54 times 10 to the negative 4. Now here we have to keep track of the zeros here. 1, 2, 3, 4, 5, 6. 6.89 times 10 to the negative 6. Not too bad. And again, you'll be practicing. Now here we have numbers that are in scientific notation, and we want to put them, going to need that room there, into standard form. Okay. Well, our number is 103, and I have to add how many decimal places here? Well, there's 2, so I'm starting there, sort of. Well, exactly there. And I need 6 decimal places to move it. So how many zeros do I add to get 6 places here? Well, I have to add 4 more zeros. And now I just move it. 1, 2, 3, 4, 5, 6. There's my answer. Now here I have a number, 8.7. Now it's going to be a small number, but how many decimal places do I have to add this way now to make it a small number? Well, 5. So there's 1. So how many zeros do I need to add? Well, I have 1, so I need to add 4 zeros. 1, 2, 3, 4. And I usually put an extra 0 to mark the place. Okay, so there's my number, 6003. So in a sense, I have 3 decimal places. I have to add how many more zeros? I have 3, got to add 7. So 1, 2, 3, 4, 5, 6, 7. There's my number. And then I have 202 with my decimal point there. How many zeros do I have to add? Well, I have to have 3 decimal places, so there's 1. So I have to add 2 more zeros. I kind of ran out of space there. 1, 2, 3, and there's my answer. Okay. Now again, your practice and your quiz me's will help determine how much practice you need to do, and you want to get your mastery points. I'm going to clear this up here. Okay, so we have our last little kinds of things to go over. Now here, we're going to, in a sense, sort of do a FOIL, but it's as if they were conjugates. We're only going to multiply this and this, and then this and this. So 6 times 9 is 54 times 10, and then here this is a 5, and this is a negative 9, so this is going to give me negative 4. Now, I have it sort of in the form of scientific notation, but is this a number between 1 and 10? No. So the decimals here, I have to move this over 1. So I now get 5.4 times. Now, when I move it over to the right, I actually have a positive exponent that I have to add. So this is going to be times 10 to the negative 3. And that should be there somewhere here. Oh, that's scientific notation. They don't want it in scientific notation. They want you just to multiply it and give you an answer. So this is my answer, but now I have to convert it back into standard form. So how many decimal places do I have to add there? Well, 3. There's 1. So I have to add 2 zeros, 5, 4, and that will be my answer. That's what we have down here. Okay, you should always read the instructions too. I thought I was pretty good on that, but I guess I didn't do too well. Okay, now we have this. So we're going to divide this. Can you all see we get a 3? And this then moves up, becomes a positive 2, and this gives you 3 times 10 to the 5th power. Now that would be scientific notation. So how many zeros do we have to add? Well, the decimal is there. We have to add 5 zeros. So 1, 2, 3, 4, 5. And there's my answer. Again, sometimes they want you to leave it in scientific notation. But here they just said, do it. They're not really telling you that here, huh? Again, we pointed this out. The base of our negative 3 exponent is just the A. So you don't bring the 8 down. This is wrong. Okay, we're one more lesson to go.